Hello guys, welcome to my channel. Okay, today's question is the sequence 1 by n, that means 1 by 2, 1 by 3, 1 by 4 is a Cauchy sequence. Okay, we have to prove this sequence as a Cauchy sequence. Okay, and definitely then 1 by n, the sequence 1 by n is what is convergent. Okay, and as we know this sequence is convergent, so this should have Cauchy sequence. Okay, how we can prove it? Let proof. Okay, before proof it, we have to make a rough calculation to find out the natural number or the positive integer which exists the Cauchy criteria. Okay, how we can prove it? Okay, as we know what is the Cauchy sequence. Okay, Cauchy sequence, we can write about the Cauchy sequence that, okay, the sequence xn is a Cauchy sequence, okay, when to epsilon greater than 0 there exists a natural number or positive integer n, okay, such that we have mn greater than equal to n and 1 by for the xn we can write it is what we write xn minus xm less than epsilon. Okay, this is the definition of Cauchy sequence. Okay, but as in the task of the sequence 1 by n, okay, what we have to need, we should show 1 by n minus 1 by m less than epsilon, okay, for all mn greater than equal to n. Okay, when we split this, we can write it is as less than equal to 1 by n plus 1 by m. Okay, and this should be less than epsilon. Okay, so how we can this one is exist when our n, that means our 1 by n is less than epsilon by 2. Okay, so we must choose a natural number n greater than 2 by epsilon. Okay, if we choose this natural number, we definitely get the proof. Okay, so now come on the proof. Okay, let to epsilon greater than 0, okay, we have we have, so we write epsilon greater than 0, we have a natural number or positive integer capital N greater than 2 by epsilon. Okay, and this one definitely exists by Archimedean principle. Archimedean says for any real number we have a natural number greater than that real number. Okay, so for epsilon greater than 0, this is any real, so 2 by epsilon is any real. Okay, so we have a natural number, we must have a natural number capital N greater than 2 by epsilon. Okay, so to epsilon greater than 0 we have a positive integer capital N greater than 2 by epsilon. Okay, then what we write, then for all mn greater than equal to this n, okay, the absolute difference of 1 by n minus 1 by m is less than equal to 1 by n plus mod 1 by m. Okay, and this one is less than 1 by capital N plus 1 by capital N. How it is? Okay, since our m and n is greater than equal to n, okay, as we write here, so 1 by n is what? 1 by n, when we make cross multiplication, because both are the positive integers, so 1 by n is less than 1 by capital N. Okay, so 1 by n, and this is exist for both m and n, so both these terms is less than 1 by n. Okay, now we have to choose n greater than 2 by epsilon, as you see here, n greater than 2 by epsilon. So definitely 1 by n is what? 1 by n is less than epsilon by 2. Okay, so both of the 1 by n, this one is less than epsilon by 2 plus epsilon by 2, so this is equal to epsilon. Okay, that we get the Cauchy criteria for a natural number capital N greater than 2 by epsilon. We get this absolute difference is less than epsilon. Okay, this completes the proof of Cauchy criteria, Cauchy theorem. Okay, that's why we can say this sequence is Cauchy sequence. Okay, thank you for watching.